Having a public API has become a standard for any modern application. No matter the type of the application, being able to share data with other applications has become a must-have feature. Whether you have a small application which has a simple backend service or large-scale apps made of multiple microservices, serverless functions, or legacy web applications, Azure API Management Service can help you create a unified API front. Orchestrate the consumption of your services by developers. The capabilities of Azure API Management Service will help us create centralized API endpoints, abstracting our internal infrastructure. It's important that we have consumption rules protecting our API from misuse. After deploying our API using policies, we are going to create rules to determine how often an API can be called, from where, as well as verify if a user is authenticated or not. Using the developer portal, we are going to make our API discoverable, so developers can test and integrate the API with their applications. And finally, the integration of API Management Service with Application Insights will enable us to visualize all of our API components and the interaction with each other to understand the API performance and identify the services which are at fault. My name is Nertil, and let's get started creating our public API in the cloud. Before we get started, there are a few things that you should know. Throughout this course, we are going to make a web API available to the public using Azure API Management Service. First, we are going to make use of an ASP.NET 5 API, which will serve as our backend. If you are not familiar with Visual Studio or ASP.NET, I suggest you watch the course Building Web APIs with ASP.NET Core before continuing, so you can get the most out of the demos in this course. In any case, you can use the API of your choice as long as it is publicly available. Not to worry, you will have all the exercise files used in this course, and we will perform each action step by step. Let's get started. With more and more companies adopting microservices and serverless functions, the backend is no longer a single API, but rather multiple independent endpoints that consumer applications need to connect to. Unifying all these different endpoints and making them available through a central place is very important for proper developer experience, as well as managing future updates. Building such an API is complicated, and we have to take a lot of things into consideration. First, we have to have versioning. Every time we change an API, the old version needs to be there in order for developers who are already using it. In order to prevent API misuse, we need to add some throttling logic. For example, limit the number of requests that can be made under a minute or so. We also have to have security in order to prevent unauthorized access. We also have to have logging. This is one of the most important concepts in web applications or any other application. In order to understand how our application is performing, we need to have logs that we can look into. And also, developers need a place where they can find the different endpoints our API has, as well as the definitions for them. They need to know what type of parameters they need to pass and what sort of data is returned. And that's where Azure API Management Service comes in. It's a hybrid multi-cloud management platform for APIs across any environment. It gives us a way to create consistent and modern API gateways for our backend services managed all in one central place. The API Management Service enables us to quickly create API endpoints and map them to our backend services, which can be anything from microservices to serverless functions, or legacy web applications without exposing the underlying infrastructure. All good APIs need documentation, a way for developers to discover the different endpoints, understand the parameters that need to be passed, and the results that are returned. Using the built-in developer portal, API management allows us to have a customizable interface where developers can view the different APIs, request subscriptions, and test using the built-in testing utilities, allowing for a great developer experience. Since most of our APIs are public, we need to have safeguards in place to protect our API from being misused. And Azure API Management Service has us covered. Using the built-in policies or by creating custom policies, we can set rules for usage of the API. Starting from limiting the number of requests in a given period of time, also known as throttling, to limiting payload sizes or blocking IP addresses. For any scenario that we might need to create a rule, there is either a built-in policy or we can create a custom one. If our API requires authentication, which in most cases they do, in an environment made of multiple backends, it becomes complicated to set up, as we need to do that for each different backend service that we have. With Azure API Management Service, we can check for authentication before contacting our backends and validate the user credentials. And last but not least, we have logging. Whether we want to figure out errors or see how our API is being used, logging is a must in every application. The Azure API Management Service has integration with Azure Application Insights to automatically log any and all activity of our API. This enables us to quickly resolve errors as well as understand how our API is being used. In the logs, we are able to look up errors or view the requests and where they are coming from. For example, we can see which region has the most requests, etc. We are going to take a look at all these features as we build our API management project throughout the course. In this demo, we are going to create our first API management project. From the Azure portal on the homepage, let's go ahead and find the Azure API Management Service. We can quickly find it by typing API. And the service name is API Management Services. We can start creating a new project using the Add button. On the Create API Management project, first, we need to select a subscription. In my case, I only have one subscription. But if you have more than one, then make sure to select the correct one. Next, we need to select a resource group. In order to be able to delete all the resources that come with the API Management Service, then it's better to create a new resource group and delete it at the end. In our case, we are going to create a new one. And let's name it API Test Group. Next, we need to provide the instance details. The region, in this case, doesn't matter since we are doing a demo API, but for production purposes, make sure you select the region where your customer base is. Next, we need to provide the resource name. The resource name needs to be unique. And in our case, let's name it Products API. And it looks like Products API is already in use by someone, so let's add a prefix to it. Let's name it LinkedIn Learning Products API. And it looks like it's available. Next, we need to specify an organization name. This will be used for the developer portal and for email notifications. So, whenever a developer receives an email, it will have the organization name in. Let's name it LinkedIn Demo Organization. And we also need an administrator email. This is a very important setting, as here all system-related notification will be sent. Whenever something is wrong with our API or someone requests a new subscription, an email will be sent here. And now that we have specified the instance details, let's go ahead and move to pricing. In the pricing, we have a couple of options. We have developer, which has no service level agreement and is meant only for testing purposes. To view more details on the pricing, let's go ahead and click the Learn More link. And here, we need to navigate to the pricing details. Now, the pricing is not going to be the same for every region. For example, for Central US, the price per unit on the consumption tier is $4.20, but if we move to something else, like East US, then the price is 3.5 per million calls. So, when you are looking at pricing, make sure you have the appropriate region set up. Here, we can see the pricing details for every tier. Consumption is a lightweight serverless version of the API management service, and it's built per execution. For East US, the pricing is 3.5 per million calls, and we have the first 1 million calls free. This is a very good option, although the one drawback is that it has no developer portal. If we navigate down, we can see that developer portal is set to no. Next, we have the developer pricing tier, which is set for non-production purposes and evaluation only. It's priced reasonably at $0.07 per hour. For entry level, we can use a basic pricing tier, which is set at $0.21 per hour. If we have a medium-sized API, then we can go with standard, which is priced at almost $1 per hour. And if we have a high-volume enterprise production case, then we can go with the premium tier, which is priced at almost $4 per hour, or $3.83 per hour in this region. We also have an isolated tier, but it's still in preview, so we don't have all the details and it's not available for everyone. For our demo, we are going to choose developer tier. Let's go ahead and navigate back to our API configuration page. We also have a couple of options that we can look at. We have monitoring, scaling, virtual network, protocol, etc. We are going to look at all these options later on throughout our course, so for this demo, let's go ahead and click Review and Create, as all the required properties we have already set. And it looks like the validation has passed, so we can create our API project using the Create button. Once our API project has been created, we'll continue adding our first API in the next clip. Once our API project has been created, we can see it in the API Management Services homepage. Let's go ahead and click on the name to view the details. Here, on the overview page, we can see the gateway URL. This is important as from here we are going to call our API. In our case, the gateway URL is LinkedIn Learning Products API.AzureAPI.net. At this point, we don't have any APIs, so let's go ahead and create our first API. To create APIs, we need to navigate to the API sections and click the APIs link. Here, we have a couple of options for creating an API. First, we have the blank API option. If we don't have the backend services ready yet, then we can create a blank API. Or, if we have the backend services ready, then we can import the definition from them. We can use the OpenAPI definition, or we can use the Web Application Description Language, or WADL for short, or Web Services Definition Language, or WSDL. Depending on which one you use, then you can import your API definition directly. Next, if we have a logic app, then we can plug it in from here, as well as if our API is hosted on app service, then we can connect it directly from here. Although this option will not import the API definitions, just connect the API. And if we have a serverless function that we need to map to an endpoint, then we can use the function app option. For our demo, we are going to use blank API, since the backend is not ready yet. Let's go ahead and choose the blank API option. First, let's go ahead and give it a display name. This will act like a label, and will be displayed in the UI and in the developer portal. Let's name it Demo. And the actual name needs to be a URL valid name, so in this case, it's Demo as well. Since our backend is not ready, we don't have a URL yet, but if our backend was ready, then we specify the URL for the backend here. For now, we are going to leave it as empty. And next, we can specify an API URL suffix. For example, depending on the API type, we can provide a suffix. In our case, it could be products, so let's type in products. And now the base URL changes. It's LinkedIn Products API.AzureAPI.net/products. Let's go ahead and create our API. Now that we have our API, the API does not have any endpoints. We have the API but no operations for it. To add an operation, we can use the Add Operation button. For the operation first, we need to provide a display name. This will be used in the UI. Let's name it Demo Listing Products. Next, we need to provide the URL. First, we need to provide the schema. In this case, it's going to be get since we are listing products. And we need to provide the URL for the resource. Let's go ahead and do list products. We can optionally provide a description. This is very helpful for the developer portal. Let's go ahead and write a simple description. And if we want it, we can provide tags, but in this case, it doesn't matter. Next, we can configure the parameters and the output that this API endpoint returns. First, we can change the query. Here, we can add query parameters that our API accepts. Let's go ahead and add a parameter. Let's name it product type. Let's add a simple description. And we can provide a type for this parameter. In our case, it's going to be string. We can optionally provide default values that this will have. This is useful for the developer portal. And we can mark it as required or not. If it's marked as required, then this parameter must be passed. Let's go ahead and mark it as required. Next, we can add headers. Just like we did with query parameters, we can add a header and mark it as required or not. For example, we can add content type, or we can add a parameter that is required throughout the entire API. For example, a tenant ID. Let's keep the API simple and leave the header list empty. In the request section, we can't change anything because the request is get and the request body is empty. But if a request was post or put, then we could change it here. And next, we have the responses. Here, we can define response status codes, content type examples, and schemas. For example, let's go ahead and add a response. One of the most common responses is 200 OK. Here, we can add a description. Let's write a description that indicates that the list of products is returned successfully. And next, we need to add a representation. Here, we need to add an output. Using the Add Representation button, let's go ahead and look for application.json. As this is the content type that we return. If we add multiple ones, then developers can see it in the developer portal. And now that we have a representation, we can add a definition. This will represent the sort of data that we return. Let's go ahead and add a new one. Let's name the definition product list. And add a sample JSON. Let's say we want a name property and the type property and the price. And here we can see that the payload is generated automatically for us. We have a return type of an array with items, with type object, and then the properties. Let's go ahead and create the definition. And here in the sample, we can see what our API would return, so the developers can see it as well. Now, let's go ahead and save the changes. And here, we can see the responses our API returns. It has a 200 OK status code response with a product list, and it requires a product type. To test our API, we can navigate to the test console. And as we can see, automatically we have a product type that we must type in. The UI derives this information from the configuration we provided earlier. Let's go ahead and type test. And let's go ahead and send it. Currently, it's going to fail because we don't have any backend. We are going to look at configuring a mock response in our next clip. Up until now, we created an API and we added an operation. The operation name was demo listing products. Whenever we call this API, let's go ahead and type a product type. We get a 500 internal server error. That's because our API is not connected to anything. The backend does not exist yet, and we have not specified the backend. So, this response is normal. In a lot of cases, when you are designing an API, the backend might not be ready yet, but you want your front-end developers to continue working. And, in order for them to do so, the API needs to exist. To enable this scenario, we can add something called a mock response. Whenever an API is called, it would not call a backend, but rather return some mock data. So the front-end developers can continue working. And we are going to do the same in this case. Since our backend is not ready, we are going to return a mock response. To do that, let's navigate to the Design tab. Here, we need to select the operation, which in this case is Demo Listing Pro, and we need to add the policy. In the API Management project, anything will be handled by policies. Whenever we have a request, it will look at policies that it needs to execute and then return the results based on those. Policies can be executed in 3 stages. In the inbound, before they hit the backend, during the backend, or after they hit the backend and return the response. In our case, we don't have the backend yet, so we want the policy to be executed before hitting the backend, which is going to be in the inbound processing. Here, we can add the policy using the Add Policy button. And we have a number of pre-made policies. The one we want is called Mock Response. We are going to look at other policies throughout the course. For now, we are going to use the Mock Response. Here, the only option we pass is the representation. And if we look at the representation list, we can see that we have a 200 OK status code, application JSON, successful listing of records that we created earlier. So let's go ahead and select this one. And now click Save Changes. And if we enable mocking, we can see here that says mocking is enabled. Now let's go to the Test tab and call our API again. Let's specify a value in the product type. Since we made it as required, we need to specify one. And let's go ahead and send the request. And now the request was successful. If we scroll down, we can see the output, which is an array that has only one object, with a name test, a type drink, and a price of 33, since this was the only object that we specified in the definition. If we added more, then we can see more here. At this point, we created an API and we added an operation. Since there was no backend, we mocked the data that this operation returns. So, the front-end developers can continue working. And whenever the backend becomes available, we can map it by removing the mocking. Currently, we are calling the API using the test console, but we can do the same using another facility, for example, using Postman. Let's go ahead and select the URL, which has the endpoint, list products, and then the product type test. And now, let's try to call it using Postman. We can see that we get access denied. That's because we are not specifying a subscription ID, and a subscription ID is required. Here, in the settings, we can either get a subscription ID, or we can make it so a subscription ID is not required. To remove the subscription ID, we need to go to Settings and uncheck the Subscription Required checkbox. Unchecking the requiring of subscription is not a good practice, as subscription is used as a means of tracking user requests. For example, we could limit the number of requests a specific subscription can make under a minute rather than using the IP, as the IP can change. Let's navigate back to the Test tab. And here we have the HTTP request. Here, on the HTTP request, we can make it so we can view the subscription, clicking the small eye icon. First, let's go ahead and copy the subscription header name. Here, on our Postman request, we need to navigate to Headers and provide our header name. Next, we need to get a subscription key. Now that we have a subscription key, let's go ahead and resend the request. And as we can see, we get data. Getting a subscription key this way is not recommended, as this subscription is used for internal testing only. But we are going to take a look at acquiring subscriptions later on in the course. In this challenge, I'd like you to create an API with the following properties. The API must have an operation with HTTP schema GET and a resource of list users. The operation must have a required header named tenant ID with type string, and return a list of users as mock data. The definition for the list of users is up to you. To solve this challenge first, I started by creating a new blank API. I gave it a display name of challenge demo. And for the API URL suffix, I gave the value challenge. So I could separate it with a previous API, which was products. And then I proceeded to create the API. Once the API was created, I proceeded to add a new operation using the add operation button. For the display name, I named it list users. And on the URL, the HTTP schema, I left it as get, and in the resource, I provided the list users keyword. And left the description blank. Since my requirement was to add a required header, I moved to the Headers tab and added a new header. In the name, I named it as tenant ID and provided a simple description. And in the type, I set the type as string and marked the header as required. And finally, I navigated to the Responses tab, and here I added a new response. For the response type, I chose status 200 OK, and in the representations, I added a new one, application JSON. And proceeded to create a new definition in the definition section. In the definition name, I provided the name challenge users and provided the sample JSON. Once I provided the sample JSON, which has three properties, a name, a tenant, and is active or not, then the payload was auto-generated. Here we have an output of type array with items, object, and the properties, which is the name, the tenant, and is active or not, which is set to Boolean automatically. Next, I created the definition. Now that I had the definition, I went ahead and saved the changes. One last thing that we had to do in this challenge is to return mock data. So I navigated to the operation list users, and in the inbound processing, I clicked the Add New Policy button. Here, I proceeded to add a new mock response. And in the list of responses, I chose 200 OK application JSON. And saved the changes. And finally, to test the setup, I navigated to the Test tab. First, I could see that in the query parameters, I did not have to add any value. That's good because I did not request any. Next, I have a tenant ID value that I need to specify in the headers, which is good as that's what we wanted. So let's go ahead and specify a value. And now we can send the request. And as we can see, the sample data is returned, which has the name, the tenant, and is active or not. Which means our endpoint is working properly and returning sample data. Before we continue with the development of our Azure API Management project, first, let's take a look at our backend service that we are going to use throughout the course. This is an ASP.NET 5 API project. Before you open the project, make sure that you have installed the .NET 5 framework. As seen here in the project properties, the target framework is .NET 5.0. The project has no external dependencies. It uses an in-memory DB, so all the data is stored in memory, and whenever the service restarts, then the data will be lost. Also, it auto-generates some data when it's initialized, so you can get up and running without having to create data yourself. If you want to change what sort of data is generated, then you can do that as well. The logic for generating data will be found in the seedData class. Here, you can see the data that is added. We are using Entity Framework and using the Model Builder, which has the hasData functionality, and we are passing in the data. To change the data, you need to do that in the respective functions. The getProductCategories returns product categories, the getProducts returns products, and price history and rank history. Now, Let's go ahead and start our project. The project has built-in OpenAPI definition setup using Swagger. Here, we can see the list of our endpoints. We have an endpoint to get a price history, then we have CRUD operations for product and product categories, and an endpoint to get the rank history. Let's go ahead and test one of these endpoints. Let's get the list of products. We can do that using the Try It Out button. And click the Execute button since there are no parameters required. And here we can see the list of results. We have a category name, a name, description, price, and the category ID. As you can see, the category and the name do not match. The category in this case is industrial and the name is pants. That's because our data is auto-generated and should not be used for real-world scenarios. Now, before we can use our API, we need to publish it. Let's navigate back to our Visual Studio. There are multiple ways to publish a project on Azure. We are going to go with publishing from Visual Studio. From the Solution Explorer, we need to right-click on the project. And we can publish using the Publish button. Here, I already have a published profile, but for this demo, I'm going to create a new one. First, we need to select the target. In our case, it's Azure. Next, we need to select the type of service that we want to deploy. For our demo, we are going to go with Azure App Service for Windows. And now, we need to create an App Service instance. We can do that using the plus button. Visual Studio will automatically pre-fill the default options. If we have only one subscription, then it will choose that one, then a resource group and a hosting plan. And for our demo, I'm going to leave them as defaults, but you can change them if you want to. For example, you can choose a different resource group. Here, when we created our Azure API Management project, it was on the group API Test Group, so I'm going to use the same. And now, let's go ahead and create it. Now that we have our app service instance, let's go ahead and move to the next page. Visual Studio also has the option to connect to an API management project, and we can do that from here. We can select our API management project that we created earlier, but we don't want to do this here as we are going to do that from the API management project interface. So let's go ahead and skip this step. And now let's go ahead and finish. This will create a publish definition for us, and now we just need to click the Publish button. We are going to continue with importing this project into our Azure API Management project in the next clip. Our Products API now has been published successfully to Azure, and here's the link where we can access the API. Let's go ahead and try it out. By default, we are going to get page not found. Let's go ahead and navigate to Swagger. And now we can see the Swagger definition. And here's the server for our API. Just to make sure it works, let's go ahead and list the products again. And we get the list of products again. But this time around, the list of products is different. That's because it's auto-generated data and it's generated always when the application starts. Now, we are going to import this API and consume it through our Azure API Management project. First, we need the OpenAPI definition URL. We can get that using the link here, where it says Swagger version 1 swagger.json. If we click, then we get the OpenAPI definition, and the version is 3.0.1. We have the title for our API and the version, and a list of servers. And then the paths for all of our endpoints. Now, let's go ahead and copy this URL and navigate to our API Management project. Let's go ahead and navigate to the API section. And this time we're going to create a new API, but we're going to import using the OpenAPI option. We could either use the URL or upload the file, which contains the definition. Since we have the URL, let's go ahead and use the URL. Next, we need to specify the display name and the name, and as we can see, it's automatically filled from the OpenAPI definition. And since this is a products API, let's add the suffix of products. And go ahead and create our API. And as we can notice, the error says that we cannot use the products suffix. That's because when we created our demo API, we used the product suffix. And since all these APIs fall under the same URL, we cannot reuse it. For our demo, let's change the products to products API. This is a limitation you'll reach when creating APIs. If you have more than one, then the suffix needs to be unique. And now, after importing, we can see all the operations that were created for our API. We have the price history endpoint, the product category CRUD operations, and the product CRUD operation, as well as the rank history. Before, when we created our API from scratch, we had to do all of this ourselves. And imagine if you have a lot of endpoints, doing it manually could result in a lot of work and probably a lot of mistakes. So, in a lot of cases, you'd want to import using an OpenAPI definition. Now, let's go ahead and look at one of the endpoints. To easily visualize them, you can group operations by tags by using Group by Tag checkbox. And now you have them all grouped nicely, so you can expand only the ones you want. Let's go ahead and inspect one of the operations. Let's use a getProductList. Here we can see the front end, which is /products, and then the definitions created for this one, as well as the backend is pointing to. Now, let's go ahead and add this operation just to see the properties the OpenAPI definition import set for us. As we can see, the display name is products get, so this is automatically appended. Then we have the name and the URL, which is /products. There is no description as our OpenAPI definition did not have one, and it automatically has the tag products. Now, if we look at the query, we don't have any query parameters as this method does not have, as well as headers. Since it's a GET request, it does not have a body, but we should have responses. And indeed we do. We have a 200 OK response. Just like the one we created earlier when we created our demo API, the import has automatically created this for us. We have content type text plain, application JSON, and text JSON. So we have 3 representations and the definition they return. And here we can look at the sample responses. So this returns an array with products inside. And let's look at something that has a required parameter. Let's go to price history. And this operation should have a parameter named product ID. And as we can see here, we have product ID, which is required. And if we look at the definition, we can see that in the template, which is a route template, we have a product ID parameter. And it has a description and a type of string. And if we were to test this API using the testing console, you would see that we need to add this value before we can continue. Otherwise, we cannot call the API. As we can see, using the import functionality, the Azure API Management service automatically created an API for us and mapped it to the backend. It created the right parameters, the right templates, and the right outputs. After importing, if we want to make changes, then we can go right ahead and edit any of these properties. We will continue with consuming the API that we just created in the next clip. Now that we have our API set up, we have the backend and we have the API management project connecting to it. Let's go ahead and look at consuming it. The best way developers are going to consume your API is through the developer portal. The developer portal is a place where the API endpoints can be discovered, users can request subscriptions, and test them. Before we can open the developer portal first, let's go ahead and make sure it's published. We need to navigate to the developer portal section and click on Portal Overview. Here, we need to make sure that we publish our developer portal using the Publish button. As well as make sure cores are enabled, because we are going to call our API from the developer portal URL, which is LinkedIn Products API.developer.azureapi.net. Then, CORS need to be enabled to allow this origin. Now that the developer portal is published and we have CORS enabled, let's go ahead and copy the URL here. And let's open it in a new window, somewhere where we are not logged in. Otherwise, we'll get the editing menu, which we'll look at it later on. Let's go ahead and open a new window. And this is a developer portal. All of these can be changed. We can change the background, the company name, etc. This is a default page that Azure API Service sets up for us. To view the APIs, we need to navigate to the API section. And here, we already have 3 APIs, but none of them show. That's because, in order for an API to be publicly visible, it needs to be connected to a product. If we navigate to the products page, here we can see that we have 2 products set up. We have Starter and Unlimited. Products are a way to bundle APIs together. For example, if we connect our API to both Starter and Unlimited, then users can purchase the API differently. By default, we can offer a Starter version, which, in this case, they will be able to make 5 calls per minute and 100 calls per week. This will allow developers to test the API before purchasing an upgraded product, which can be unlimited or anything in between that we can add. Basically, the product is what we are selling, and through the product, developers can use the API. Now, let's go back to our API management configuration. And here, we can navigate to the product section. And we can see that we have 2 products. To assign a product to an API, let's go ahead and navigate to the API section. And here, we need to choose an API that we need to assign a product on. Let's go ahead and choose our API. And let's navigate to the settings page. Here, we have an option to set the products. Let's go ahead and assign both products. Now, let's save the changes and navigate back to our developer portal. If we navigate back to the APIs, we should see our one API that we assigned the product on. And here we have the LinkedIn CORS API. Let's navigate to it. And now we can see all the endpoints this API provides. To make it easier, let's group them by tag. And now we can see them as we were viewing them in the testing console. But this is for everybody. Each developer can come here and see what we offer, the different endpoints and the results they return. For example, let's navigate to products. And here we can see the URL, we can see the response types, which have text plain, application JSON, and text JSON, as well as the output. If we click on the type, we see the object that is returned, which has a name, description, price, category ID, and ID. To test the API, we can use the built-in testing console by using the Try It button on the top right corner. Although right now, it's asking for a subscription. If we call it without subscription, we'll get an error. Let's try it without subscription. As we can see, we get unauthorized as a subscription ID is required. If we have a subscription, we can paste it here. Otherwise, we need to sign up and purchase a product. To sign up, we can use the sign up button. Here, we provide the details and then we click sign up. I already had signed up, so I'm not doing it again, but after you sign up, make sure to check your email for a verification link, and it might be in the junk folder. Now, let's go ahead and sign in. Once signed in, if I use a Try It console, I still don't have a subscription ID. That's because I haven't purchased the product yet. Let's go ahead and navigate to the product section. And here, let's purchase the starter program, as this does not require an administrator approval. In order to subscribe, we need to provide a name for our subscription. Let's call it testing. And hit subscribe. and now we are redirected to our profile where we can view our subscriptions. I had already created a subscription named Demo and cancelled it, and we see it here, and now we see the testing subscription, and it's active. Here we can view the primary key or the secondary key, and then we can regenerate them if we want in order to improve our security so the key doesn't stay the same for a long time. But now that we are logged in, we don't actually need to copy the primary key here for testing. Let's go ahead and navigate to our APIs. And let's call the product list. As soon as we navigate to the try console, now, instead of a text box, we are provided with our subscriptions. And here we have the testing subscription. We can either use the primary key or the secondary key. For our demo, let's use the primary key. And here as well we can see starter, which is a product name. If you subscribe to other products, then we'd see them here. And as we can see, the subscription is pre-filled in the headers now. Let's go ahead and call the API to test it. And we have success. We can see the list of product names. The developer portal is a great tool for discovering the APIs. So, each developer, before they can continue working, can see what the results are and what parameters need to be passed. At the same time, they can use a built-in console to test the different endpoints, and based on the parameters, the UI will provide them the necessary UI to call the API. After publishing your API, the next step would be to make some changes. After a while, you might want to change a name, a description, or add another endpoint. And you can do that. You can just go to the operation you want to change, and then change the name, description, etc. But as soon as you do that, then the changes go live. And there is no way for you to go back on those changes. For example, if you change the description, if you want to undo it, you'd go to the property and then change the description as it was before. So, you have to know what it was before in order to change it back. A better way to make changes is to use revisions. Revisions in the Azure API services act as a draft. You can prepare some changes, and as soon as you are ready to make them live, you can push them. And the benefit is that you can go back on those changes anytime. Just go to the previous revision and make that one active. Let's go ahead and see how to add a new revision. To create revisions, we need to go to the Revisions tab. And right now, we have only one revision, which was created on March 26th. And as we can see in the properties, it's online and it's current. To add a new one, we just need to click the Add Revision button. And we need to add a description for the revision. Let's go ahead and add a simple description. And as soon as we hit create, this revision will be created for us. Now that this revision has been created, we can see it at the header, where it says Revision 2. And we can go back to Revision 1 anytime. Just hit the drop-down menu and then select Revision 1. And all API properties will be shown for the Revision 1. Now let's go back to the Design tab and make a change. For our demo, let's change the rank history endpoint. In the front-end tab, let's open the form-based editor and let's change the display name. The rank history returns a list of products and how they're ranked over time. So let's change the display name to Product Popularity. And let's add the description as well. Now let's go ahead and save the changes. As soon as we do, on the left side, where the operations are listed, we can see now that the name has changed. Let's go ahead and move back to Revision 1. In the Revision 1, we can see that the name is as it used to be, so we can go back anytime from one revision to another. As well as we can use revisions to see how our API has evolved over time. Now, let's go to the Revisions tab. And let's make this revision active now. On the Action menu, on the revision, we need to click the Make Current option. When we make a revision current, we have the option to post a change log. let's go ahead and check the checkbox and write a simple change log. And now let's go ahead and save the changes. As we can see now, revision 1 is not current anymore, and we can see at the top that revision 2 has a blue color, which means it's active. To view the changes, let's navigate to the developer portal, and let's refresh to make sure we have the latest changes. Let's navigate to our API, which is LinkedIn Learning API course, and here we should see the change. And indeed, the name now says Product Popularity. And we can see the description as well, which says Product Popularity over time. Now, developers also can view the changelog. By navigating to the changelog link, we can see what changed over time. And here are the notes for when we made revision 2 active, which says changelog for demo revision as we typed it in. Using revisions is a great way for us to manage our API over time and go back on any change that we want. This way, if we break our API or make a change that we did not mean to, or we did it by mistake, then we can go back on it by moving to the older revision. We'll take a look on how to add an API version on the next clip. After our API has been published and is being utilized by developers, new feedback has come in and we are requested to make a change. The price history endpoint, which has a list of price changes over the years for a specific product, needs to change. Here, the output for the price history is as following. We have an ID, we have the new price, the change date, the product ID, and product name. So, instead of returning the new price, we are going to return by how much the price changed. So, we are going to return a property called price change and remove the new price property. But, since developers are already using this endpoint, we cannot just remove it. In order to achieve this, we need to add a new version. Let's go ahead and navigate to our API and see how we can add a new version. To add a new version, we need to click on the options on the specific API and use the Add Version option. This will ask us a couple of questions on how we want to add a new version. First, we have the version identifier. In our case, we are going to specify it as v2. But this could be anything. It could be just 2, version 2, or anything that you'd like. Next, we need to specify the versioning schema. Here we have 3 options. We can specify the version identifier in the path, in the header, or in the query string. Depending on your use case, you'd need to choose the appropriate option. For our demo, we are going to use header. I find header being the most convenient way to add a version as the URL does not change, but we just specify a header for the version of the API that we want to use. Next, we need to specify the version header. Let's specify API version. But this also could be anything. This is the name of the header where we need to specify the version. And finally, we need to specify a full API version name, as this will be displayed in the developer portal. Let's do LinkedIn API course version 2. Now, when we create a new version for an API, this becomes its own API. So, it will have its own policies, descriptions, products, anything that is related to an API. By default, it will inherit everything that was from the original API, and when we change it, those changes will be only applied to this version. So let's go ahead and select the products. Remember, without selecting products, this will not show in the developer portal. And finally, let's go ahead and create our new version. And here now, we have the original one and version 2. We can switch between the two and make changes appropriately. Now, before we can continue further, we need to change our backend service. Here, in our backend service, we are going to add a new endpoint. The endpoint will have the keyword v2 in front of product, so it's going to be price history /v2/product/product ID. And instead of new price, we are returning price change, so it's going to be new price minus old price. Now, let's go ahead and publish these changes to our Azure API backend service. To publish, we need to navigate to the Solution Explorer, right-click on the project, and publish. Since we already have published the API before, we have all the settings set up. We just need to hit publish and a new version will be published. Now that the changes are published, let's make sure that the new endpoint is available. Here, on the Swagger definition, let's go ahead and refresh to view the latest changes. And now we can see another endpoint, which is price history /v2. Let's navigate back to our API definition. And here we are going to change the price history. Now, the first way of doing it is by modifying the front end. Here we can change the URL, because anything passed after the base API, which is our API URL /products API, will be forwarded to the backend. So, this section here, price history /product ID, will be forwarded to the backend. And in here, we can add v2. But this will not be appropriate, as now the URL changes. We have to specify v2 as well as change the URL. So, changing it here is not a good option, as this is like adding a new endpoint rather than adding a version to an existing endpoint. Let's go ahead and discard the changes here. The way we can change where we point to the backend without changing the URL is by policies. We are going to take a look at policies later on in detail, but for now, we are going to add a policy in the inbound processing. Here, let's use the Add Policy button, but first, make sure that you are on the v2 API, not the original one. Let's go ahead and click the Add Policy button, and we are going to use a Rewrite URL policy. This will change the URL coming in to something that we want to hit in the backend. So, whenever price, history, product ID comes in, we want to change it to price history, v2, then product, and then the product ID. This now will call a different endpoint as specified here. We can see that the URL for the new endpoint is price history v2 product ID. Let's go ahead and save the changes. And now, let's navigate to the developer portal. Let's go ahead and move to the APIs list. And now here we should see two APIs. One is the original one and the other one is version 2. It doesn't matter which option we choose, as we can change the API version in here as well. Right now we are on the original, and we can move to the v2 by selecting the v2. And now we are using the v2 API. In order to test the price history, first we need a product ID. So let's navigate to products and get a list of products. Here in the headers, we can see that the v2 API version is being specified. But for products it doesn't matter, as that endpoint hasn't changed. And now, let's copy the ID of the first product and navigate to the price history endpoint. Now, let's go ahead and make a call. Our subscription key is being provided automatically since we are logged in, and we need to provide a product ID, which is a required parameter. The API version is being set, so we just need to call the API. And now, we have the new results. Instead of new price, we have price change. And the rest of the properties are the same as we did not change them. To make sure this is working properly, let's go ahead and remove the API version, so we call the original one. And now, let's call our API again. And we get the old data, which has new price instead of price change. One last thing that we need to change is the definition. Here, on the price history, for developers who are trying to understand what sort of data this API returns, if they look at the price history view model, they will see that it still says new price instead of price change. Let's navigate back to our API, and we are on the v2 version, so if we look at the price history endpoint, we can see the definitions. If we click on one of them, it will say that it points to the schema price history view model. So let's go ahead and find that schema. And price history view model is here. Let's go ahead and open it. And here, we only need to make a small change. Instead of new price, we need to type price change. This does not affect the data that the API is returning, but rather only the OpenAPI definition that we have on the developer portal. Now, let's go ahead and save the changes and navigate back to the developer portal. To make sure we have the latest changes, let's go ahead and refresh. Now, let's look at the price history view model, and we should see the property now is price change. At this point, we have successfully created a new version for our API. Using versioning is a great way to support breaking changes for our API over time, and the Azure API Management service makes it very easy for us and straightforward to set up new versions. In this challenge, I would like you to add a new version to our API. Since we already have version 2, you need to add version 3. For the version schema, use header, and the endpoint that you need to change is the rank history endpoint. This endpoint now needs to point to the new backend service URL, which is rank history v2 product ID. The actual URL on the API should not change, but you should use a URL rewrite policy to change the backend URL. And also, you need to change the definition, so the definition matches the new endpoint from our backend service. You'll find the new endpoint for our backend service in the exercise files. To solve this challenge, first, I proceeded to add a new version to the API. I added a new version onto version 2. So, from the version 2 context menu, I used the add version option. For the version identifier, I used v3. And for the versioning schema, I chose header. Next, for the version header, I specified API version. And finally, I provided a full API version name, which was LinkedIn API Course version 3. And in order for my API to become publicly available on the developer portal, I chose the products. And finally, proceeded to create a new version. Before I could continue further, I made sure to publish the latest code for our backend service. The code for this exercise, you can find it in the exercise files, and it contains a new endpoint for rank history, which returns a rank change property instead of rank. And as a URL, it has a v2/product/product ID. Next, I proceeded to publish the API. Once my API was published, then I made sure that the endpoint was live. By navigating to the OpenAPI definition for the API, I refresh the page and make sure that the new rank history endpoint was available and live. Next, I navigated back to the Azure portal. Here, in the portal, even though after creating a new version it's by default selected, there is a small bug where even though version 3 is selected, actually the endpoints here are for version 2. So any changes you make will be applied to version 2, and your changes will not work properly. So before you continue, make sure you refresh the entire page first. And now let's select version 3. And the endpoint we need to change is rank history. Let's go ahead and find it. It should be at the very bottom. And since we cannot change the front-end URL, we are going to change the back-end URL using a policy. I proceeded to add a new policy in the inbound processing. And for the policy type, I used rewrite URL. I changed the URL from rank history product to rank history version 2 product. And I made sure this URL matches with the Swagger UI definition. So it's rank history version 2 product ID. And finally, I proceeded to save the changes. Next, I navigated to the developer portal to make sure the changes were working. In the API list now, I could see my API version 3, which I just created. In order to test my endpoint, first I need a product ID, since as a parameter it's required. So first, I call the products API to get the ID of one of the products. Once I had the ID, next I proceeded to call the rank history endpoint. I specified the product ID that I copied earlier and made sure that the API version was version 3. And finally called the API. And it looks like my changes were successful, as we have now the rank change property instead of rank. And just to test, let's call the original API or the version 2 API. Let's change v3 to v2, and this change should not be in v2. And as we can see, the rank change property is no more, but we have the rank property. So, only developers using the version 3 of the API will get the change. One last change that I needed to make is change the definition. Here, the rank history view model still has a property for rank, but in version 3, the property name is rank change. So, I navigated to the API Management portal, and here in the definitions page, I clicked on one of the definitions. And I could see that the items reference the rank history view model schema. Next, I found the rank history view model and changed the rank property into rank change. And finally, saved the changes. Next, I navigated back to the developer portal to make sure the changes were live. Once I refreshed the page, the new changes were available. And now, the property name is rank change. One of the most important concepts in the Azure API Management are policies. Using policies, we can set any rule for our API, and we have actually used two of them until now. We used for returning a mocking response, as well as setting the backend URL. Policies have 4 stages where they can be executed during the lifetime of a request. First, we have inbound processing. This would be executed as soon as the API is called. These policies are the first to be executed and will determine if the request should proceed any further or not. For example, here we can have course or authentication policies to determine if we should forward the request to the backend or not. Next, we have backend policies. These are executed when the call is made to the backend. In our case, this would be executed when we call our products API that is hosted on Azure. Once a request is made to the backend and we have a response, then the outbound policies are executed. At this point, we have the response from the API and we can change it if we need. We can transform it into whatever version that we want it to. For example, we can add or remove headers from the response. And finally, we have error policies. If for any reason there is an error during the execution, the on-error policies would be called. These policies serve as error handling within Azure Management API, where we can perform different actions based on the error. Besides the order of execution, we also have scopes for policies. First, we have the global scope. The global scope policies are top-level policies configured for all APIs. To configure a global policy for all APIs, we need to click on All APIs link, and at this point, we need to set the policy. We can set it into the inbound processing, backend, or outbound, and this will be executed for all APIs. Next, we have product scope policies. We have briefly looked at products until now, but they are a way so we can bundle different services together. For example, until now, we had the starter and ultimate products. If you navigate to the products, here, each product can have its own policies, and they are executed after the global scope. So, for whatever product the developer has purchased the API, then the policies for that product will be executed. If we navigate to the starter, we can go to the policies section, and here we can see the policies. We have inbound, backend, outbound, and on error. And we can see that the starter has a rate limiting policy. We are going to look later on how to create a rate limiting policy with our API. But Whenever an API is called using this product, then this policy will take place in the inbound processing. So, this will be executed after the global scope. If we don't have anything on the global scope, then this will be the first to be executed. And, as we can see here, we are limiting calls 5 for a period of 60. And here as well, we can add other policies. But, rate limiting and quota are the most common that we could add to a product. If you navigate back to the unlimited product, in the policies section, we should not have any policies. That's because the unlimited one does not have any limits, so no quota policies apply to this one. After the product scope, we have the API scope. If you navigate to an API and select a specific one, here now we have multiple versions, so we need to select the appropriate version. Inside our API, when we have selected all operations, then any policy here that we apply will be applied to all operations. That means this policy is in the API scope. All operations will inherit it. And finally, we have the operation scope. Here, the policies are applied to just this operation. If we go to version 2, we have a policy for the price history. And this policy, which is a rewrite URL policy, is only applied to this operation. If we were to apply it up here for the entire API, then our entire API would be broken. But for our entire API, we might apply an authentication policy or a course policy. Policies are a very powerful feature that we should take advantage when we are developing our API. We should move all the API usage rules that we might have on the backend into our Azure API Management frontend. So, our backend service only gets hit if all the requirements are satisfied. We are going to take a look at implementing different policies in the clips to come. In this demo, we are going to apply a rate limiting policy to one of our APIs. Currently, any API that is consumed to the starter product will have a rate limiting policy applied. But we are going to also apply a rate limiting policy to one of the endpoints. Let's go ahead and apply it to version 3. Here, let's go ahead and apply a rate limiting policy to the price history. At this point, we are applying a rate limiting policy to an operation, so this will be the last one executed on the scope. And rate policies need to be applied to the front end, as that's the first step of the execution. To add a rate policy, let's navigate to the inbound processing and add another policy. Here, we have the limit call rate policy by key, which is one of the default policies that we can easily apply. This will use the key and then apply the rate limiting based on the key. Let's go ahead and select it. And now, we need to specify how many calls can be made. Let's say we only want to allow one call every 10 seconds. So we need to specify 1 in the number of calls and 10 in the renewal period. And next we have a counter key. Now here we have a couple of options. We can use the API subscription, which is a good way so anyone who has an API subscription can call the API, or we can use an API address. Although keep in mind that the API address for the caller might change at any time. But if we choose API address, then every time a call is made, if the API is the same, then another call will not be allowed for another 10 seconds. For now, let's go with API subscription. And next, we need to choose increment condition. Here, we need to define if any request will increment or only successful ones. It's a good option to make it any request, as if somebody makes too many requests but they fail, then they would not be incremented, and you could have a DDoS attack. And let's save the changes. Now, we made changes to version 3 of our API, so when we call it, we need to make sure that we are calling version 3. Let's go to the developer portal, and now let's call the price history endpoint. Again, to call the price history, we need a product ID, so let's go ahead and get one. Once we have the product list, let's go ahead and copy the ID of the first one. Now, let's go ahead and navigate to the product history endpoint. And let's try this out. Let's specify the product ID as it's required, and we are hitting the API version 3. We should be allowed to make the first request, and we get data, and if we make another one, we should not be allowed to. And indeed, we get too many requests. Rate limit has exceeded, and we need to try again in 6 seconds. Since the renewal period was 10 seconds, during the request processing and rendering, we lose about 4 seconds. And if we try again now, we should be able to make one. And if we try again, we are not able to. Rate limiting policies are a great way for us to manage how our API is being used. Using the rate limiting policy in the products, we can specify how many calls a specific product can make. Since we can provide products with different prices for different needs, then this is a great way to manage the requests. As well as we can add a global rate limit policy or per operation limit policy. For example, if we have an API which is heavy on resources and should not be called too often, then we could specify a rate limiting policy on that resource only. This way, we can lighten the load of our backend and make sure our API is operational for all developers out there. Whenever we make a call to our API, we can see the headers returned, and we can see headers returned from the backend. We can see here X powered by ASP.NET. This header is from our backend, and this exposes the framework that we are using for this API. Now, we can use policies to remove the headers that we don't want or add new ones. As well as we can edit the headers on the fly. Let's navigate back to our API, and here we are going to add a global header for all APIs. Since we want the header for our backend not to be shown anywhere. Now, to manipulate headers for the response, we need to do that in the outbound processing, as this is the step before the request is returned to the caller. Let's go ahead and add a new policy, and here we have the option to set headers. First, we need to choose a header name. Next, we need to choose a value that we want to assign to it, and then we need to choose an action. We can either override, skip, append, or delete. In our case, we don't want to append any value or override the value. We want to delete the header, so we need to choose the delete option. And now, let's save the changes. Let's navigate back to our developer portal, and let's try to make the request again. And now, the X powered by header is gone. Manipulating headers on the fly is a great way for us to manage the headers returned to the response. Since our API could be made out of multiple backends. There could be multiple .NET APIs, Node APIs, or Azure serverless functions. And each of those will add custom headers when they respond. So, we can remove them or change them on the fly when the response is returned. Optionally, we could add additional headers. For example, if our applications require a specific header all the time, then we could add a header to the response so all backends don't have to return this header, but the API management service will take care of it. Let's go ahead and add a new header, just to see how it looks. And here, we need to add the header on outbound processing, of course. We can set the header, and here, let's specify a name. And for the value, let's set it to override, as this header does not exist in the response already. And now, let's add a value. This isn't very helpful header, but in your case, you would add your own custom headers. Now, let's go ahead and test this. When we make a call, we should see the header that we just added here. And we have test header ABC. In this case, you would add your own headers. Now, we also have the option to set headers on the request when it's coming in. Let's navigate back to our API management. And in the inbound processing, we could also set headers on the request. For example, if our backend requires a header to be available in order to process the request, but the caller does not send it, then we can also specify it in the inbound processing. We could add a policy in inbound, and then we could use a set header. This now will set the header on the request rather than response. For example, we can set the header for tenant ID. If our backend requires a tenant, then we can specify the tenant here. And we can override it or append it or whatever we want. And now, whenever a request is made, this value will be passed to the backend. So, if the backend requires a header, then we can specify it here as well. Or we can transform the header before we send it to the backend. Using policies, the Azure API Management service offers us a great way to transform headers in the request and also in the response. Another important API setting that needs to be set are CORS. If our API is to be consumed by client application, then CORS needs to be enabled. And for our API, when we deployed our API to the developer portal, we set up CORS by default. If we navigate to the All API section, which means here we can see global policies, in the inbound processing we can see a policy called CORS. If we open the definition, we can see the properties. And we can see that the origin that's allowed is our developer portal. Here we can choose allowed methods, allowed headers, exposed headers, and allowing credentials or not, as well as the maximum age of a pre-flight request. Now, CORS are a setting that you might need to enable globally for all APIs, unless you have specific use cases where you might need to enable them for a specific API or endpoint. So, client applications need to access this API as well. If your API is only to be used by your organization, then you can set the allowed origins here. Let's go ahead and change this API a little and see what happens with our developer portal. Now, let's save the changes and navigate to our developer portal. Here, when we make a request, we should have a CORS issue. And indeed we do. Since the browser initiates the request, it requires cross-origin resource sharing. And our URL is not on the list of allowed CORS origins. Now, let's navigate back and change the policy again. Now, let's change the allowed origins to allow anything. To do that, we can use a wildcard. This will allow all origins, but there is a problem. When we allow all origins, we cannot use allow credentials. So, if we have requests that need to send credentials, this will not work. If we try to click save, we'll get a warning. And it indicates that we cannot allow all origins on a resource that supports credentials. Let's go ahead and say allow credentials no. And now let's save the changes. Our developer portal now should be able to access the API unless they send credentials. And it looks like the developer portal does not send any credentials, so the request is successful. Depending on the usage of the API, you will enable CORS differently. If you have to allow all origins, then, unfortunately, you cannot allow credentials, so it's a trade-off between what you have to allow and if you have to use credentials. But if it's a public API, then using credentials is not going to be a requirement. But for internal APIs, then you can specify only the URLs that you need to. Up until now, we have only used the built-in policies provided by the UI, where we would go to inbound or outbound and use the Add Policy button. This only gives us a subset of policies that we can do. If we have a simple scenario, then the built-in policies in the UI will suffice. But in most cases, you'd want to do more advanced scenarios. And API Management Service has a lot of other policies that we can use. To view all the policies, we can navigate to the documentation. Here, in the advanced policies, we have a set of policies that we can use. We have control flow, where we can do if-else scenarios, or we can forward a request, log events to Event Hub, and much more. Now, we don't have time to go through all of them, but for our demo, we are going to do a control flow policy. let's go ahead and click on the control flow policy. And here we can see the statement. The statement has a root tag choose, which starts the policy, and then inside we can have when tags and otherwise. Now, at least one when tag is required, as when we do an if-else, the first if is always required in C#. And then we can have another when, and finally we can have otherwise. The otherwise tag is not required, and we don't have to have it here. If the first condition matches, then all the policies inside the first when will be executed. Or, if the second condition matches, then these policies will be executed, and finally, if we have an otherwise tag, these policies would be executed if none of the above matched. The policy expression in Azure API Management Service is based on C#. Microsoft offers a detailed documentation about the policy expression, which you can find here. Currently, this documentation is for C#7, but it might change later. Each policy has access to a variable called context. The context variable will contain information about the API, the error, the operation, the request, the response, subscription, user, variables, etc. We can use all this information to make decisions when we execute our policy. Now, let's navigate back to our API management project. And here, we are going to create a policy that the user can use to request mock data instead of real data. We are going to execute our policy in inbound processing. So we can check if user requested mock data, then we can return mock data. Otherwise, we are going to return actual data by calling the backend. To open the policy editor, we can use this code icon here. And in here, we have the policies for all operations, so this is API-wide. Although, keep in mind that this is only for version 3, as we are working with version 3 right now. Here, we have inbound policies, backend policies, outbound, and on error. Now, any policy that we set in the inbound will be executed on the inbound section. Let's go ahead and add our policy. First, here in the policy, what I'm doing is setting a variable. We have a policy called setVariable that we can use to set a variable. This way, we can reuse this variable throughout the policy execution. I'm setting the variable name to isMock and checking the request headers. So context, this is a context variable that we talked about earlier. And here we are accessing the request. From the request, we are getting headers, and then we are getting the value or the default. And the header name is going to be data type. Here we are checking if data type is mock. So if the data type is mock, then this variable will be set to true, otherwise false. Now that we have our variable, we can create our control flow policy. The control flow policy starts with choose, so choose is the root tag. And then we have the conditions. For our demo, we only need one when condition. So if the data is mock, then we are returning a mock response. Otherwise, we'll leave the request proceed as intended. Now, in our when condition, we look at context.variables. So, in order to access the isMock variable that we declared up here, we do that in the variables. And we use getValue or default, which is boolean, and then we pass in the name. And if this matches, then we are returning a mock response for status code 200 and content type application JSON. Now, let's go ahead and save the changes. We can remove the otherwise because we don't need it, and it's also empty as well. Now that we save the changes, let's go ahead and look at the inbound processing. We can see now the policy. We have the base one, and then we have the set variable, and we have choose. So choose when, if the when matches, then mock response. And as we can see up here, it says mocking is enabled. Although it's enabled conditionally, if we apply a mock response policy, then this warning will show up here. Now, let's go ahead and test our API. We applied the policy in version 3, so let's go ahead and navigate to version 3. And we applied our policy API-wide, so it doesn't matter which API we call. So let's go ahead and call products. As soon as we make the request, we should see actual data from the backend. That's because the policy is not applied yet. And we do get actual data. Now, let's go ahead and add a header. The header name was data type. And the value to match is mock. And now, let's go ahead and resend the request. This time around, we should get mock data. And indeed we do. We only get one record, that's because mock data returns only one record for us, and we have the properties here. They don't get actual values, but they have the type, so name, string, description, etc. And now we have successfully created a more advanced policy where we applied a control flow policy. You can look at the documentation to view all the different policies that you can apply to your API. If an exact policy that does what you want it to do does not exist, chances are that combining two or more will give you the actual result that you want. In this demo, we are going to look at how to catch errors in our policies. If we go to the policy editor, it doesn't matter if it's in the inbound or outbound, we have the on error section. Here, we can add policies that will be executed if something goes wrong in our previous policy executions. For example, we can return the error message to the user if we wanted to. Here, we are using the setHeader policy. We are specifying the name as error message, and if it already exists, then we are overriding it. For the value, we are using the last error property of the context object, and the last error property has a message. To view all the properties a context variable has and what properties each object has, we can navigate to the documentation, and in the policy expression section, we have all the properties the context variable has. And if it's a complex object, then we have the properties of that object as well. If you navigate to the last error object, and here we can see all the properties. It has a message that we are using, a scope, a section, a path, a policy ID, to identify the policy that failed, etc. And you can use any of those. Now, let's navigate back to our policy manager. For our demo, setting the error message in a header will be enough. If you are not sure what the definition of a policy is, then you can use snippets. You can go to the snippets and then select the appropriate one that you want to insert. For example, if we want to do a mock response, if something goes wrong, then we can do that here. Now that we have a policy set, so whenever an error occurs, we are setting the error, let's go ahead and save the changes. Now, there is no way for us to properly test this, as all of the operations work, but let's go ahead and break one of them. Let's change the products endpoint. We need to navigate to the backend and open the editor, and here let's override the service URL and change it to something that's not reachable. Now, let's go ahead and save the changes. And now, let's test the API. We modified the products endpoint, so let's go ahead and try the products endpoint. As soon as we try, we should see an error and the error message should be in the header. And indeed we do. We have 500 internal server error. So, something went wrong, but we don't know why. And in the error message we can see that the remote name could not be resolved, as we changed it to something unreachable. You can use the onError section for policy execution for multiple use cases. You can return a mock response, you can change the response that you return, or you can redirect the user somewhere else. Depending on your scenario, you can implement any of the policies in there. When we are creating complex policies, right now, without being able to debug, we would have to save the changes, try the API, and see if everything is okay. But there is a better way of doing that. And we do that using Visual Studio Code. This new feature by Microsoft allows us to debug API policies in real time. First, let's go ahead and install the API Management extension. And the extension name is Azure API Management. Let's go ahead and install it. This might take a while to install, but I had installed it previously, so it was instantly. After installing, you should see an Azure icon on the left sidebar. And now, here we have our subscription. And inside the subscription, we have the API. I was already logged in before, so it kept me logged in. But if you are not signed in, then just double click and it will open a browser tab where you can log in. And then you'd have the same view as I have. Here we can inspect our API. And we have the APIs, gateways, the global policies and products. Now, let's open our APIs. And here we can see our 3 APIs. Our LinkedIn API course has 3 versions. And the latest changes are on version 3. So let's go ahead and open that version. And in here, we can see the policy. This policy is applied globally to the entire API. And in here, we have our mock response control flow, where if the data is mocked, then we return a mock response. And we have error handling here. Now, let's go ahead and see how to debug this policy. To debug a policy, first, we need to debug an operation. So, in our case, it's going to be products. Products has its own policy as well, which is operation level policy. And in our case here, we are setting the backend service URL to something that's not unreachable. So it throws an error. To debug a policy, we need to right-click on the operation and use the Start Policy Debugging option. This will automatically open a console where we have the subscription key for us and then some trace information used by the debugger. One thing to keep in mind is that here a version is not specified. So, if we call it right away, this will not be called in version 3, but rather version 1 or the original version. And in our case, we have 3 versions, so we need to specify the version ourselves. And here we can do API version, and in our case it's v3. And now we can send the request using the send request link here. And now we get the policy debugging. Here, the first policy that is being executed is the set backend service URL, which is an operational level policy. And that's because we set the base after the policy. In order for other policies to be executed before, we need to set the base before. So anything in the base would be API level, product level, and then global level. Those would be executed in order before coming here. Now, let's step over. And now, we can move to the global policy, which are the course policies. After which, we move to the API level policy, where we check if data is mock. And here, the data was not mocked, so we move to forward the request to the backend. And now, we reach the on-error policy section. Since the backend did not exist, this policy will be executed where we set the error message. And now, let's go ahead and step over this one as well. And now, our request was successful. Or rather, the request failed, but the debugging process was successful. The request status code is 500 as expected, and we can see the error message here saying the remote name could not be resolved. Now, let's go back and make the request again. But this time, let's set the data type to mock. In this execution, the backend should never be called. Okay, so first we are setting the backend service URL, then we should move to course, and now we are checking if the data is mock. And since the condition is met, now we are returning a mock response. And here now we can see data and there is no error message. Using this debugger feature with Visual Studio Code will give you power to create your policies and make sure they are working properly before making them live. And you can easily debug any errors that you might encounter right in from the debugger. In this challenge, I'd like you to create a control flow policy and apply it to the products API. Whenever a request comes in, which has the header admin with the value yes, and set the backend URL for the products API to admin/products. Otherwise, leave the request to proceed without making any changes. To solve the challenge, first I navigated to the products operation and the operation that lists all products. Here, I created a policy in inbound processing. First, I set a variable with the name isAdmin, and I get this value from the header admin and check it if it's equal to yes. Any value other than yes would mean that isAdmin is false. So, if the value is yes, then isAdmin is set to true. Next, I added a control flow policy. First, I start with choose, and then we have the when condition. If the variable admin is set to true, then I rewrite the URL from products to admin/products. And finally, save the changes. Next, I tested the endpoint using the developer portal. First, if I did not set any header, then the result would be fine, and I would get the data from the backend. Next, I tried setting the header admin, and with the value yes. When I make the request now, it says not found, and that's because the admin/products does not exist on the backend and is not found. So, we know our policy is working successfully. Until now, whenever we have called our API, the only way that we were authenticated was via subscription key. So, whenever we navigate to the developer portal, if you try to make a request, we can see that the subscription ID is being provided. Now, if we remove it, then we'll get unauthorized response. That's because a subscription key is required for API, and that's how it should be. And as we can see here, our on-error policy is also adding the message access denied due to missing subscription key. Now, a subscription key doesn't have to be required for an API. If we navigate back to our API, in the settings, we can actually change whether a subscription is required or not. Here, if we uncheck the checkbox and then hit Save Changes, for version 3 now, subscription should not be required. And let's try a request again. And indeed, we do get data. But it's not recommended for you to remove the subscription key, because it can be used to track requests, see who those requests belong to, as well as limit the number of requests a subscription can make. So, it's a great way for tracking, as well as limiting people who can use the API. Whoever wants to use the API, then they can buy a subscription, and then on top of other authentication methods, they can actually use a subscription. But if for some reason you are calling the API from a client application, then a subscription is not a great way, as you would expose the subscription key on the browser and people can steal it. So, on those scenarios, we are going to use other authentication methods like OpenID or OAuth authentication, as well as client certificates. Now, let's go back and enable our subscription. Here, on the subscription details, we can see how a subscription should be passed. It could either be passed by header or a query parameter, and the name of the header is specified here as well as the query parameter. The name of the header here is very long, and in most cases, you'd want to change it. So, let's make the header subscription key. And let's go ahead and save the changes. Now, let's navigate to our developer portal and refresh to see the latest changes. If you try to make a request, now it says subscription key, and the subscription key now is being passed on the header value subscription key. Let's try and make a request. And indeed now the request was successful. For cases where subscription key is not enough, we are going to look at implementing other authentication methods like OpenID or client certificate. We are going to implement OAuth with Azure Active Directory in the next clip. In this demo, we are going to add authentication to our API using Azure Active Directory. First, we need to navigate to the developer portal. In here, we need to navigate to OAuth 2 and OpenID, and we are going to create a new OAuth 2 server definition. Let's go ahead and get started using the Add button. First, we need to provide it with a name. Let's name it Azure Active Directory. Next, for the client registration page, we don't have one, so we are going to provide localhost. We are going to leave the authorization grant types to authorization code, and we need the authorization endpoint URL and token endpoint URL. This is important information that the developer portal will use to get the token from Azure Active Directory. We can get that information from the Microsoft OpenID well-known configuration, which can be found at the following URL: login.microsoft.online, then common, version 2, well-known, and then OpenID. Let's go ahead and get the authorization endpoint. Next, let's get the token endpoint. And now, we need three other important settings. First, we need a client ID, client secret, and also we need a default scope. This will be used for the developer portal to get the token. To get a client ID and client secret, we need to create an application registration with Azure Active Directory. Let's open two tabs side by side so we can get the necessary information back and forward. First, we need to navigate to the application registration service. And now, let's go ahead and create a new one using the new registration button. Let's name it API Client. And for the account types, we are going to allow any organization, which will include Microsoft accounts as well, like Skype, Xbox, etc. Depending on your use case, you might need to choose another option. If you want only to allow accounts in your own organization, then you could choose the first option. Now, let's go ahead and register our application. Now that we have our application created, let's go ahead and configure it. First, let's go ahead and copy the client ID, as this is the client ID that we are going to use with our API. Next, we need to navigate to authentication, and in here we need to add the platform. Since our application is web, we are going to use web, and we need a redirect URL after a successful login, which needs to point to our developer portal. The URL for that you are going to find in the service configuration, which is the authorization code grant flow property, which will point to our LinkedIn's product API developer portal, and then signing out, code, callback, and Azure Active Directory. Keep in mind that the last part is based on our application. If we scroll up, we can see that it uses the ID that we provide here. Next, on our application configuration, we need to configure the tokens. For our demo, we are going to use ID tokens. And now, let's go ahead and configure our application. We also need a client secret, so in our application configuration, we need to navigate to Certificates and Secrets, and in here, we need to create a new client secret. Let's give it a name, and let's go ahead and add the secret. Once the secret is created, we need to copy the value, not the ID, but the value. And now, let's go ahead and provide it in our API configuration. The last thing that we need now is the default scope. Currently, we have created a client application, but this application has no API to provide authentication against. So, we need to create another application that will serve as our server. Let's navigate back to our app registration page, and let's create a new registration. Let's name it API Server. And we are going to allow any accounts in here as well. In our API server, we are not going to do the configuration we did for our client. Since this serves for the backend, we only need to expose an API. First, we need to select an application ID URL. You can leave it as default or change it to something more meaningful, depending on your use case. Now, in here, we need to add scopes. Scopes are used to verify user authorization. For example, if you have the scope profile.read, then the application will allow you to read user profile, etc. Depending on the application, you might have a lot of these ones, as you can add a scope for reading products, deleting them, creating them, reading user profiles, etc. For our case, we are only going to create one scope. Let's name it profile.read. And we are going to allow users as well to consent. And let's give it a display name. We also need to give it an admin consent description. And now, let's go ahead and add our scope. Using scopes, the backend service can determine if the user has the right to read the profile or not. If the user has this scope, then they have the right, otherwise they can't. And finally, we need to connect our client application to the server application. We can do that using the Add a Client Application button. In here, we need to provide the client ID, which was the client ID we specified on our API configuration. And also, we need to select the authorized scopes. And that's it. Our app configuration now is complete. And now we have completed the authentication configuration. One last thing that we need to add on our API configuration is the default scope. In our case, we need to copy the scope name that we created in our API here. And let's go ahead and paste that in. And now the default scope will be profile.read, and we can go ahead and create it. Now that we have the server created, let's go ahead and navigate to our API. In here, we are going to change the original version. We need to navigate to Settings, and then we need to navigate to the Security section. Here, for authorization, we need to choose OAuth 2, and we need to select the server that we created, which was Azure Active Directory. Now, let's go ahead and save the changes. One last step is we need to publish the developer portal, so it has the latest changes. In the portal overview, we can quickly publish it. And now, let's go ahead and navigate to the developer portal to test our API. In the developer portal, make sure you refresh so you get the latest changes. Now, let's navigate to version 1 of our API. And let's go ahead and try the Products API. In here, we should get authorization, and we do. The name of the authorization server that we created. In here, we can use authorization code, and this will pop up a window for us to sign in. First, we need to consent to the permissions. And now, we should have an authorization code. And the authorization code is passed in the headers. Although we are passing an authorization code, the API will not validate this one, as the configuration we made till now were only for the developer portal. So developers can come here and quickly sign in with their account and test the API. If we remove the authorization code and send the request, we are still going to get data. That's because no authorization is verified on the server. We are going to learn how to verify the authorization code in our next clip. Previously, we configured our developer portal so it allows users to sign in and get an authorization code. When we select authorization code, a window pops up and we are allowed to sign in, and now we can get an authorization code. and that authorization code is passed in the headers, which is a JSON Web Token. Let's go ahead and copy this to see the properties it has. We can view JSON Web Tokens in the jwt.io website. In here, we paste our token and then we can see the payload on the right. As we can see, it has my name and then the username and some other properties. But the properties we care about is the audience. In our case, we can see the audience here. And this property should be the same as our API server application that we created. If we copy this and navigate to our API server configuration, the application ID should match. And indeed it does. The application ID is the same. So this is the audience that our API will validate the token for. Now, let's go ahead and navigate to our API so we can validate the JSON Web Token. In our API, let's go ahead and navigate to the original one. And we need to add the policy to validate the token. And since we don't want the request to go to the backend if it's not authorized, then we need to add the policy in the inbound processing. Let's go ahead and add a new policy. And the policy type is going to be validate JSON Web Token. First, we need to specify the header where the authorization code will be found. And we are going to provide this information in the authorization header. You can change it, but common practice is that this information is provided here. Next, if the token is not valid, then we want to return 401 unauthorized. But we can return any of the other options. Next, we can provide a message that we want to return when token is not valid. Let's say token not found or invalid. And now we are going to add the audience. This is going to be our API server application ID that will look at the JSON Web Token definition. We can optionally add a claim. For example, only users who have a specific claim can be allowed to call the backend, but that is bestly done per operation as some operations have different permissions. And as a last property, we need the OpenID URL. This is going to be the OpenID well-known configuration from Microsoft. This way, our policy knows where to validate the token. And now, let's go ahead and save the changes. Now that we have our policy in place, let's go ahead and try calling the API. Let's go ahead and remove the authorization header and make a new call. This time we get 401 unauthorized. Since we did not provide the token, then it's returning 401. And here's the message: token not found or invalid. Now let's go ahead and get a token. To get a token, switch back to noauth and then back to authorization code. And now let's try a request again. And this time around we get data. And if you try to break it, for example, let's make it invalid. And we still get 401 unauthorized, as the token is invalid. Using policies is a great way to validate JSON Web Tokens. We can validate tokens globally or per operation. And if specific operations require extra claims, then we could override the global policy by adding a JSON Web Token validate policy in the operation. In this demo, we are going to authorize our clients using a client certificate. Since we don't have an actual certificate, we are going to create a new self-signed certificate. In the exercise files, you will find a script that will allow you to create a self-signed certificate. You might need to change the URL. In my case, it's LinkedIn Products API and the DNS as well as password. But I'd suggest you leave them as default and just change the URL to whatever your URL is when you created your API. Once you run the script in PowerShell, it will create a certificate like this: Azure API Certification.pfx. Next, let's navigate to our API. In our API, we need to navigate to certificates, which is found under security. Here, let's go ahead and navigate to the Certificates tab, and we need to add another certificate. I have already added mine, uploaded from the local folder, but let's go ahead and see how it looks when we add one. First, we have the choice to use between a key vault or a custom. If you use key vault, you must have a key vault service created and upload the certificate there. For our demo, let's go ahead and use custom. Let's go ahead and select the file. The file name is Azure API Certification.pfx in the exercise files. You don't have to use the one that is found in the exercise files, as the URL might not match. But you can create your own one using the script. Once we upload the file, we need to add the password. If you use the script, then the default password is password. And finally, you need to provide it an ID. I've already created the certification, so I'm not adding a new one. But once you add, it will look something like this. You have the subject, thumbprint, and when it expires. Now that we have the certificate, let's navigate back to our API. For this demo, we are going to change the version 2 of the API, so we don't mess with the version 1 that we created Open Authentication. Let's go ahead and select version 2. And now we are going to apply a policy to all operations, so all of these operations will be validated against the certificate. Let's go ahead and open the policy editor. And here I've already created a policy. Now let's go over it. We are using the control flow policy, so we start with choose, and then the condition is as following. First, we check whether the certificate is null or not on the client. If the client did not send the certificate, then we return 403 and with the message invalid client credentials. Status code 403 means forbidden, so the client is forbidden to access the resource. Next, if there was a certificate on the client, we check if the certificates we have on deployment, so that would include the certificate that we just uploaded, matches with the certificate sent from the client. So if the thumbprints match, then we allow the client to continue. Now this is a basic check, and we are only checking the thumbprint. And also for this to be more secure, we also need to check the chain of the certificate and validate the chain. But since our certificate is self-signed, we cannot validate the chain, as that will always fail. Now let's go ahead and save the changes. Now that we have the policy set up, let's navigate back to the developer portal. Here, as soon as we try to send a request, the browser will pop up a window where it allows us to select a certificate. In our case, we only have one, so let's go ahead and select this one and click OK. And we have successfully queried the API. To verify that this is not working always, let's go ahead and make a query using Postman. Here, we're making the same query and listing the products. We have a subscription key and the API version is version 2. Now, let's go ahead and try to make a request. We should get 403 denied. And we do 403 invalid client certificate. So, our client certification is working properly. Now, you don't want to use client certificate with everybody, but for internal purposes or for server-to-server usage, client certificates are great. In this challenge, I would like you to add authentication using Azure Active Directory. You have to configure OAuth authentication with the developer portal, as well as create a policy to verify the JSON Web Tokens from Azure Active Directory. Once you are done, join me in the next clip to go over the solution. To solve this challenge, first, I started by creating a new app registration. For the account types, I allowed all account types, and I named it API Challenge Server. Next, I proceeded to create the client application, and I named it API Challenge Client, and for the account types, I allowed all account types. Next, I copied the client ID of the application and navigated back to the server. In the API challenge server, I navigated to exposing an endpoint and proceeded to add a new scope. I left the application ID URI as default and proceeded to continue. Once the application was set, then I created a new scope. I named the scope Profile Challenge and allowed administrators and users to consent. Next, I provided the consent with a display name and added the description. And finally, created the scope. Next, I proceeded to add a client application to our server one. Using the ID of the client application, I selected the authorized scopes, which was Profile Challenge, and created the application. Next, I navigated back to our API, and the API portal I navigated to the developer portal settings and in the OAuth 2 settings. Here, I created a new server by using the Add button, and I named it Azure AD Challenge. Next, for the client registration page, I added localhost, and for the authorization grant type, I left it as authorization code, and in the authorization endpoint URL, I provided the value from Microsoft well-known configuration about Open Identity and the token endpoint, which is token. And finally, I needed to get the client credentials and the default scope. By navigating back to the application registration page, I was able to get the default scope and paste it into the default scope here. Next, I proceeded to get the client ID for the client application. In the application registration list, I chose the API challenge client and I copied the client ID, as we need to provide the application client ID, not the server one. Once I had the client ID, I proceeded to create a new secret. By navigating to the Certificates and Secrets section, I created a new secret. Here, I provided the description and left the expiry in 1 year. And proceeded to copy the value in the secret data. Now that I had the secret, all I need to do is copy the authorization code grant flow URL, as we need this as the callback URL. Once we copy this, let's go ahead and create our service. Now, let's navigate back to our application registration page. In our API challenge client, we need to navigate to authentication. And here, we need to add a platform. Our platform is going to be web, and I entered the URL for successful redirect after login, which I copied from Azure API Management project. Next, I selected the ID token and then click Configure. One last thing that we need from application registration is the server client ID. Let's navigate back to application registrations and select the server. Here, we need to copy the ID. Once I had the ID, I navigated back to my API management project and navigated back to the API that I wanted to change. Once in the API project for the challenge, I proceeded to change version 3, as the original version was already set up with authentication, version 2 had client certificates, and version 3 had no authentication. In the settings, I navigated to security and chose OAuth 2, and for the server, I used the Azure Active Directory challenge and proceeded to save the changes. One last thing that I needed to do is create the policy to verify the JSON Web Token. In the inbound processing, I added a new policy to validate the JW token. I set the header name as authorization and left the HTTP code for failed 401, and the validation message I set to challenge unauthorized. For OpenID URLs, I specified the well-known configuration for Microsoft. And finally, I needed to add an audience. The audience is the application registration for the server, the client ID of the server application. And now that I had the audience, I went ahead and clicked Save Changes. Before I could continue to the developer portal, I first made sure to publish all the changes. Next, I navigated to the developer portal and used API version 3. And as soon as I try the product list, I get the Azure AD Challenge authentication. Here, if I choose authorization code, then I should get the pop-up to log in. And indeed I do. Since it's the first time of me logging in, I need to authorize this. And now I should have an authentication token, which I do. And finally, I called the API using authentication token, which was successful. To make sure it's working, I changed the authentication token to something that is not valid and tried the request again. And now I got unauthorized, so my authentication was set up. Up until now, we have used the developer portal to only test our API, and the design has not changed. All the logos and the text are the defaults by Microsoft, which are for the Contoso firm. To open the developer portal in edit mode, we can use the developer portal link from here. Once we navigate it, we are automatically signed in and we get to edit the site. And as we can see, we have the controls here. The site editor is just like any other site editor that you might have encountered. If we hover over an item, we get to change it. For example, let's go ahead and change the logo here. Once we click on it, then we get the edit button, or we can remove it altogether. Let's go ahead and edit it. Here, we get to change the properties, and if we click on the source, we get to change the image. This will bring out the media library. In the exercise files, you should find a file named logo.png. Let's go ahead and upload the logo.png file. And now, we can see that the logo is appearing. And the logo says Products API. It's not a fancy logo, but just to demonstrate. Next, we can change other properties, like the header here, for example. Let's go ahead and edit it. And we can type whatever we want. For example, we can change the color if we wanted to, or add text. Let's say, welcome to our APIs. Here on the left, we have the navigation menu. We can change pages. From here, we can add a new page or change how an existing page looks. Next, we have the media library where we uploaded our logo. And here, we get to delete items or download them if we needed to. You can use the download button or the delete button, as well as change the name. Next, we have the layouts. Currently, we have two of them. The default and home, and we get to add a new one or edit the existing ones. An important setting is the navigation menu. Here is a navigation menu that we see up here. We have main menu and authenticated user menu. So the main menu has home, APIs and products, and the authenticated user has report, profile and sign out. Once we sign in, we see the authenticated user menu. As well as we have anonymous user menu and the home page, which says sign up. From here, we can change items. For example, if we click on home, then we can change the label. Let's name it to start. And now it will say start. Basically, it's just like any other site editor. You go onto properties that you want to change and just change them. We also have other settings like the title of the website, we can change the icon, etc. And we have some styling properties that we can change. For example, we can change how a featured button looks or a normal button looks. If we change the featured button, then the sign up button, which is a featured button, will change. Let's change the background of the featured button to red. As we can see here, we don't have a red color, but if we navigate away and we navigate to the colors, we can add a new one. Let's name it red. And now we have a color named red. If we go down to the buttons, let's go ahead and edit the button again. In the backgrounds, we should have red. And now the button is red. Or we can add another variation of the button, as well as we can change other items. Now, we can't cover all the possibilities here, but if you want to design your site, then you just have to go in here and change the properties that you need to. And finally, we have the operations. Here, we can either decide to publish the website or reset the content. As you imagine, publish the website would make these changes live, as well as save them at the same time. But resetting the content will return our website to its default state. So all the changes that we made would go away. If you don't want to publish the changes, then you can just use the save button here. This will save our changes without publishing, and whenever we are ready, we could publish from here using the publish website, or we can navigate to our API management project, and into the developer portal overview, we can use the publish site. Let's go ahead and publish it from here. And now our website is being published, and it might take a second for the changes to be live. Let's go ahead and open the developer portal in an incognito window, so we don't get the site editor and we get the latest changes that we just published. And as soon as we do, we can see that the logo has changed, the homepage has changed, and the sign up button now is red instead of yellow. So our changes are live. Using the developer portal, site editor is a powerful feature that you can customize it according to your brand. You could add your own logo and your color schema. Up until now, we have had to use only the starter product. And in our API, we have two products, starter and unlimited. If you look at the starter product, in the settings, we can see that this does not require approval. So, whenever someone requests a subscription, it will be approved automatically. If we change this to requires approval, then anyone who tries to get a subscription will need to be approved first. If we navigate to our unlimited product, in the settings, we can see that this one requires approval. So, whenever someone requires a subscription, then somebody, as an administrator, will have to approve it. Let's go ahead and add a new product. Let's name this product Pro. And let's add a description. Let's say we allow everything for this product, and this requires an approval. Before this product can be available, it also needs to be published, otherwise developers cannot see it. And in here, we can add APIs as well, or we could add the product to the API through the product editing page. Let's select the LinkedIn API course, but since our API has 3 versions, then we need to add all 3 of them. And now, let's go ahead and create our product. In the product details, we can see all the subscriptions for this product, and currently, we don't have any, except the administrator one, which is me. Now, let's go ahead and navigate to the developer portal. In here, if we navigate to the products page, we should see the new product. And currently, we do not. That's because products needs also permissions to be assigned to it. Let's navigate back to our API, and we need to navigate into the Access Control tab. As you can see, the only group who has access to this product are administrators. Let's go ahead and add another group. And we have 2 options to add, developers and guests. Let's go ahead and add both of them. That means that signed in developers can view this product, as well as guests who are not signed in can view the product. And if they want to, then they can buy it. Now, if we navigate back to our developer portal, we should see the product. Let's go ahead and refresh. And there we have it. Our Pro product is here. Let's open the details and create a subscription. Let's name it Pro and subscribe. If we look at the subscription that we just subscribed for, it says submitted, so it's not active. Somebody needs to approve the subscription. And subscriptions can be approved by a manager, administrator, or whoever has permissions. Let's navigate back to our API management page. To view the subscriptions, we need to navigate to the Subscriptions tab. In here, we have two of them, one that's submitted and one that is our administrator. The submitted one is by me, logged in as another user. At the same time, I'm also the administrator. We can switch between pending approval and all, and in the pending approval should be the newly one. Here, on the context menu, we can approve it by doing activate subscription, we can reject it or delete the subscription. Once we activate the subscription, the user should also get an email that their subscription was approved. Now, let's navigate back to our developer portal and refresh the page. And finally, we can see that our subscription is active. Now, when we try to make a call to an API, we get to choose which subscription do we use. Let's navigate to our APIs, and let's go with version 1 of our API. When we try our API, we have the option to either use the Pro subscription or the Starter one. That's it about requesting subscriptions and approving them. Whenever someone requests a subscription, the administrator will get an email as well in order to approve the subscription. Making a product require approval is a great way to allow only developers that you want to be able to use that product and call your API. Currently, in our developer portal, users can only sign in by creating an account with their own email. If you navigate to the sign up page, they need to sign up by using an email, password, and providing some other details. But there are other ways of doing this. Developer portal also supports authentication using Active Directory. Let's go ahead and navigate to our Azure API Management project, and in the developer portal, we need to navigate to identities. Here, we can see the provider type. The first one is username and password, but we can add another one. In here, we need to choose a type. Currently, we can use Azure Active Directory or Azure Active Directory B2C, and Facebook, Google, Microsoft, and Twitter are currently deprecated. And Facebook, Google, Microsoft, and Twitter are not supported anymore, and might be removed in later releases. If we select Azure Active Directory, then we need a client ID, client secret, and then the tenants that are allowed to. We would have to go in, create an app registration, and then provide these values. But there is an easier way to do this. Let's navigate to the portal overview page, and in here we have the option to enable Azure Active Directory. This will create all the necessary steps for us. It will register the application, enable access tokens, add permissions, create client secrets, and add Azure Active Directory identity in our API management. Let's go ahead and enable it. Once we enable it, if we navigate to the identities, we can see that Azure Active Directory has been added. And here we have the client ID, secret, and sign-in tenant, which is my tenant. Now, before we can continue, let's go ahead and publish the developer portal. While the portal is being published, let's navigate to our developer portal and refresh. The Azure Active Directory changes might take a while to show up, but when they do, we should find them in the sign-in page. And we can't see them yet, so let's go ahead and refresh the page again. And here we go. We have Azure Active Directory button. Let's go ahead and click it. This will bring out the sign-in page from Microsoft. And now let's go ahead and log in. Let's go ahead and consent to the permissions required. And now we are logged in to our API developer portal. If we navigate to our profile page, we should see all the necessary information. From here, we can start using product, APIs, etc. Enabling Azure Active Directory for your developer portal is great, so you can allow all the developers in your organization access to. This way, developers don't have to create their account and you can allow only specific tenants to access your APIs. Currently, our developer portal is hosted on Azure, and yes, if we wanted to, we can change the URL. But another option is to self-host a developer portal. This is just a normal website that accesses data through REST API and manage our API management service. Microsoft has a way for us to self-host a developer portal, and this might have great benefits. For example, we can self-host a developer portal internally. You will find the documentation for self-hosting in this GitHub repo. Here we have the code for the management portal and we can self-host it. First, we need to clone this, so let's go ahead and clone it locally. Now, let's go ahead and navigate into the folder. For editing the files, we are going to use Visual Studio Code, but you can use a favorite editor of your choice. Let's go ahead and open it with Visual Studio Code. And in here, there are a couple of things that we need to change. We need to navigate to source. And in here, we are going to update the config files. Let's go ahead and start with design. First, we need to change the management API URL. Now, the format for this will be a little weird. But all you need to change is the API name. In our case, it's LinkedIn Products API. The rest needs to remain the same and the XXXs need to remain there as well, as they will be automatically replaced by the application. And the last thing that you need to change is the name at the end. In our case, it's LinkedIn's Products API, which is the API name. Next, let's go ahead and change the backend URL. Here, we need to replace the service name with the name of our service, which is LinkedIn Products API. Next, we need to get an API access token. Let's navigate back to our API. Here, we need to navigate to deployment, and we need to open the Management API tab. First, we need to enable Management REST API, and from here, we can get an access token. Using the Generate button, this will give us a shared access signature that we can copy. Let's go ahead and copy this. And now we can paste this here. Now we are done on this file. Let's go ahead and change the next one, which is config.publish.json. Here we need the same. We need the Management API URL and the Management API access token. So let's go ahead and copy these two. And now we need to change our last file, which is config.runtime. Here, we only need to change the Management API URL and the backend URL. So let's go ahead and copy those in. And that's it. Now we have changed all the files that we need to. Before we can continue though, we need to install the npm packages. Let's go ahead and do npm install to install the packages. Keep in mind, this process might take a while as there are a lot of packages to install. Once the compilation process completes, then our application should be ready on localhost port 8080. If localhost port 8080 is busy, then it will take another port, 8081 or something else. So make sure you check the port correctly. And here we see, now we have the developer portal and it's hosted locally for us. And it's identical to the one we have on the developer portal on Azure. From here, we can see the list of products and everything looks great. We can also check our APIs. All of this is possible since the locally hosted developer portal uses the Management REST API to do the same operations as the live one. Now, you can get this site and host it on your own service provider. This is just like a normal site. You can get it and host it on your own service provider of your choice. Let's go ahead and look how we can publish the site. To publish the site, we need to run the command npm run publish. This process might take a while to finish, so when it is done, it's going to publish the file into a folder called dist. Once the publish process is finished, now we should have our website. If we navigate to the source folder, in here we should have a folder named dist. And inside here we should have our website. And here we go. This is the contents of our website where we can host it wherever we want now. And we'll display our API information. Another option that we can configure in the Azure API Management is the email notifications. For example, whenever we do an action like forgot password, we're going to receive an email. Let's go ahead and try it out. And now we should have received an email. And here's the email. It indicates why we are receiving the email and a link to reset our password and some other information. This is a default email that is sent, and we can also customize this. Let's navigate to our API Management project. In our API Management project, we need to navigate to Notification Templates. And here we have all the notifications that are sent. For example, the one that we received earlier was password change confirmation. And here's the template. We have the confirmation URL, the developer portal, and all the other information that we saw in the email. And here we can change this. For example, we can change the subject. Let's name it forgot password. And we also can change some other properties. In here, for example, we have the variables, or as they call them, parameters. Wherever we want to insert the first name or last name, organization name, then we can do that here. For example, let's go ahead and insert the organization name in the title. Just remove the text and then click on the variable. And that's it, this will be replaced with the organization name. And also we can do other changes, we can change the HTML format, etc. So you can adapt this to your own templates that you have for your firm. So the brand matches. And you can do that for all the email templates. Let's go ahead and save this one. We can also change any of the other emails here. So whenever a new subscription is activated or a new issue is received or we invite a user, we can change the template. Now, let's navigate back to our developer portal and try the forgot password again. Now, let's go ahead and check our email. We should get an email with the subject forgot password. Also, make sure that the email does not end up in the junk folder, as in most cases, these emails end up there. And here's our email. Forgot password, and here we have the subject, which was forgot password. And we did not change anything else besides the title. Using the email templates, you can customize them to match your own brand. This way, you can remove all the branding from Azure and then add your own. In this challenge, I would like you to enable Azure Active Directory authentication for our developer portal. First, make sure that Azure Active Directory is configured and then sign in using an Azure Active Directory account. Once you are done, join me in the next clip to go over the solution. To solve this challenge, I navigated to the developer portal settings. Here, I navigated to the portal overview and use the option Enable Azure Active Directory, as this will automatically set up all the necessary information. Once I enable Azure Active Directory, I navigated to the Identities section. And here, the Azure Active Directory provider was created for me. Next, I navigated back to the portal overview. And here, from the portal overview, I published the portal to make sure the latest changes were live. Once the portal was being published, I navigated to the developer portal to see if the changes were live. Since the developer portal takes a while to configure and be pushed live, I made sure to refresh the page to see my latest changes. And once I refreshed the page, the Azure Active Directory sign-in button was available. Next, To sign in, I use the Azure Active Directory button. First, I consented to the permission since this was the first time being logged in. And there, I was logged in using Azure Active Directory and I could view the products and APIs. Now that our API has been deployed, let's go ahead and look at monitoring, as monitoring is a very important step for us to see how our API is performing and what requests are being made and where from. For monitoring, we need to navigate to the monitoring section. And here, we have a couple of options. First, we have Analytics. Let's go ahead and open it. And here, we can see an overview of our API and what's happening with it. Let's go ahead and change the time range. You can either select one of the common ones or you can change the time range by entering a start and an end date. For us, let's go ahead and select everything that we have, which will be inside the last 90 days for sure. As we can see, we get a number of requests, and about 85 of them were successful, the rest failed. Most of them are for authorization issues, so we made a couple of requests that failed the authorization process. And some of them failed for other reasons. For example, the backend URL was not found or the backend returned an error. Next, we can see the data transfer, which is about 4 MB, and it's not a lot. We have the response times for each of our APIs as well as caching. Another useful information that we can see is geography. Here we can see where the requests are coming from. And we have two of them. One is Albania and then the other is USA. Both the requests are from me, but using a VPN I was able to set up as I was in the USA. So I made a couple of requests. And here we can see how many successful requests, unauthorized, failed, etc. In here we can see easily the countries where our API is being used from. And if we want to block a country, then we would block that country by the IP address. Next, we have details about the API. Here we can see how many requests were made to each API and each version of the API. Then we have operations. Here we get details about API operations like getting a list of products, etc. Next, we have products. In the products, we can see API requests based on the product. So we have started, unlimited and pro. And we can see how many requests are made for each. And we only have made requests using a starter. That means that the unlimited and pro have not been used yet to make a request. Next, we can see requests by subscriptions. In here, we can see the subscription ID, the subscription name, and then how many requests were made for that subscription. And here are our subscriptions that we did during testing. We did testing 1, demo, Azure test, and pro. Next, we have the users. Here, we can see requests based on users. The first user is my username that I created, and I did most of the requests using this user, but I also tried anonymously and using the administrator. This is a good overview to see which user is making the most requests or has the most failed requests. And finally, we have the actual requests. Here, we get the timestamp of the request, the method, the URL, the response code, and request size. We could use this information to see how our requests are performing and which API endpoints are being called the most. Now, this is only an overview of how our API is performing. If something went wrong, we only see that it did, but not what went wrong. To see what went wrong, we need to enable logs and query the logs to get the error messages. We are going to enable logging in our next clip. The Analytics dashboard enables us to view the API and how it's performing. We can see here that we have a response code of 500, which means something went wrong. But we don't get any actual details of what went wrong. To do that, we need to enable logging. Let's go ahead and navigate to our API. let's select one of the versions of our API. Let's go with the original one. And we need to navigate to Settings, and then into the Monitoring section. Here we have Diagnostic Logs, and we need to enable it using the Enable checkbox. Once we do, we need to select the destination. Here, I have already created the destination, but to demonstrate, we are going to go through the whole process. Let's go ahead and click on the Manage button. In here, we need to add a logger. Right now, I already have one, so for our demo, let's go ahead and add another. To create a logger, we need an Application Insights instance. Let's go ahead and create another one. Let's find Application Instance Service, and let's go ahead and open it in a new tab. Now, let's go ahead and create a new one using the Add button. For the resource group, we are going to select the same group that our API is in. That's just for convenience, so we can delete it later. Next, we need to give it a name, and then we need to select a region. We don't have workspaces, and workspaces are beyond the scope of this course, so we are going to go with a classic resource mode. And let's go ahead and create our resource. Now that our app instance is created, let's navigate back to our API management project. And in here, let's try to add the logger again. And now we get the LinkedIn API instance. Let's add a simple description so we can identify it later. And let's go ahead and create it. Now that we have a logger, let's navigate back to our API. And we were going to configure logging for the original version. Let's navigate to Settings. And let's go ahead and enable logging. Here we need to select the destination, and we need to choose LinkedIn API that we created earlier, and we are going to leave the rest of the settings as default. We are going to leave the sampling rate 100%, we are going to always log errors, as well as client IP address, and the log level will be information, and the correlation policy will be legacy. And finally, let's go ahead and save the changes. At this point now, we have configured logging for our API, which is only version 1. Any requests that we make now will be logged and we can query them. We are going to take a look at querying logs in the next clip. Now that we have configured logging, let's go ahead and make a couple of requests so we can inspect the logs. Let's navigate to our developer portal and let's try to make a couple of requests. In here, this API requires authentication, so I'm going to send a request without authentication, so we could see the errors in the logs. Let's go ahead and make a couple of them. And we can see that we get unauthorized response. Now, let's go ahead and log in. And in here, we are going to change the subscription key. So, we have some errors based on the subscription key. Let's go ahead to the headers and remove the subscription key. Or, better yet, let's go ahead and break it. Now, the request should fail. This time, it's because of the subscription key, and we get the message that the subscription key is invalid or we did not supply one. Let's go ahead and make a couple of them. And now, let's navigate to our API to investigate the logs. To find the logs, we need to navigate to Monitoring, and in here, we need to go to Application Insights. Here's our logger that we created earlier. We need to right-click on it, and we need to use the Go To button, which will open up the Application Insights. And in here, we can quickly see an overview of what has happened. One of the easiest ways to view errors is to navigate to the Failures tab. In here, we should see all the requests that have failed. And here we go. Here's our API, and we have a couple of requests that have failed. I had already made a couple of requests before. So, if you just made the request, wait a while before they can show up here. And here we have the request failure by operation. And in our case, let's go ahead and click on the get products errors. And we can see up here how many errors we have. And on the right, we can see the error types. Up here, we have top 3 error codes, which are all 401. That's because all of the failures were 401. And below, we can see the exception types. We can see that we have one for subscription key not found, one for token is not present where we did not authenticate, and one where subscription key was invalid, where we changed the subscription key. If we click on one of these, here we can see the actual error. Now let's go ahead and click on it. And in here we get end-to-end transaction details. And we can see the API that was called, which was products, and then the exception. The exception was subscription key not found. This is a very useful way for us to analyze what happens. We have the API call and then the exception, which is bundled for us all in one view. And on the right, we can see more details. We have a service type, region, call stack, etc. Now, let's navigate back to our application insight instance by clicking on it. And here, let's go ahead and query the log ourselves. Up here, we have the View in Logs option. And we have some pre-built queries. Let's go ahead and use the first one, failed request count. Once we click it, this will navigate us to the log and show us the query. And here is the query that was prepared for us, which is getting data from the request table and using a filter for time. And then it's summarizing the data for us. We can either view it in a chart or we can go to the Results tab. And here, in the Results tab, we can see the actual data. Now, let's go ahead and clear the query and see how we can query it ourselves. Here, on the left, we have the tables that we can query. And one of the tables is requests. This will contain all the requests that were made to the API. Let's go ahead and type in requests. Next, we can filter. We provide in a pipe and then we write the where keyword. And let's go ahead and filter the ones that do not have a status code of 200. We can check for status code using the result code property. And let's go ahead and make it not equal to 200. Once we run the query, this will show us results for the last 24 hours. That's because we did not specify a time range in the query. It will automatically be specified for us up here. You can go here and change it. Let's go ahead and make it last 7 days. And now we'll get more results. Now that we have data, we can see which request failed. For example, we can see the request get product that failed. And the result code was 401, but we don't know what happened. To see the exception, we need to query the exceptions table here. Let's go ahead and copy the operation ID. We can use the operation ID to query the exceptions table. That will give us all the exceptions associated with this request. Let's go ahead and type in exceptions, and then where operation ID equals the operation ID that we just copied here. And now we get the exception if we open the properties and navigate to the details. We can see the message and other details. In our case, the message was access denied due to missing subscription key. Using the query editor, you can query any properties from the request, exceptions, etc. This is a great way for us to find out what happened and what was the reason for it. In our demos, we have used a simple API where we have the Azure API Management instance that is talking to our backend API service. But in a real-world scenario, you will have different APIs, so there could be multiple backend services, serverless functions, etc. And we need a way to identify the interaction between the different components. To do that, Application Insights offers us an application map, which we can find under the Investigate section. Here, we get our Application Insights instance, and then we get the backend that is talking to. In our case, we only have one backend and one Application Insight instance. But imagine having hundreds or thousands of those. So, it would be very complicated to understand the interaction between all these components and identify which component is having trouble. Here, on the application map, we can quickly see that we have a lot of failed requests, and they are identified with a red circle. So, about 70% of the requests are failing. Next, we have our backend service, and we have an arrow indicating that this is connected to our backend service. We can see the average response time from our backend service to our API management instance is about 220 milliseconds. And if this was higher or lower, we could identify it here easily. If this becomes 1 second or more or less depending on your use case, you might look into this and see why the backend is responding so slowly. And when we have a lot of backends, then we can see which one is responding the fastest, which one is responding the slowest, as well as where are the calls going. In here, we can see the number of calls that is being forwarded to the backend. In our case, it's 3, because the rest failed and they were never sent to the backend service, but they were returned to the client, since we were either unauthenticated or our subscription key was missing. If we click on our instance, then we can view the details here, and we have our API that's failing, which has 13 failures. As well as we can see the slowest requests and some other properties. If we can't easily identify the issue here, then we can navigate to the logs and further investigate the issue and what's going on. Using the application map is a great way for us to visualize how our components are interacting with each other, and which component is having issues or which component is having the most traffic, so we could solve this problem and split the requests evenly between different backends, or we could add more backends to support the traffic. For APIs that handle a lot of traffic, for example, imagine the API from Netflix or Google, someone or multiple someones need to monitor the API continuously. This way, they can quickly identify any issue and report it. Application Insights offers us a great way for us to monitor our API in real time. And we can do that using live metrics. First, it will connect to our Azure Management API instance and it will show us results in real time. This will show us results for the last 20 seconds live. Right now, we don't have any requests coming in, so let's go ahead and make a couple. Here, I'm calling the Products API, but you can call any of the APIs. Now, let's navigate back. And here, we see the request rate, and our requests are coming through in real time. We can see incoming requests, the duration, and the failures, as well as outgoing requests, so these are the ones that are going to the backend API, and the overall health. Here, we can see the memory, the CPU, and the exception rate. Currently, we only have one server, but if we had multiple, then we would see them here. We would click on the individual server to see data just for that server. Now, let's go ahead and make a couple of requests that fail. To do that, we can change anything. For example, we can remove authentication or we can remove the subscription key. Let's go ahead and remove the subscription key. And now, let's make a couple of requests. Here, in our live metrics page, we can see the errors coming in. Here, we have the error failure rate, and here, in the dependency call failure, we don't see anything. That's because, since we didn't have a subscription, then the call was never made to the backend. So, the outgoing requests are empty. And here, we can see the exception rate and the CPU. On the right here, we have some sample telemetry data, which has some basic information about the exception and the error message for that exception. If you have an API that needs to be monitored live, for example, if the API breaks, it's a very big deal and the company is losing money, then using the live metrics dashboard is a great way for us to analyze the requests coming in and the errors happening in real time. So we could notify the right people so they can take care of it. In this demo, we are going to set up alerts. So we get notified whenever a condition meets. Let's go ahead and navigate to monitoring. Here, we need to navigate to the Alerts tab. I have already set up an alert, so I have alerts here already. Let's go ahead and add a new one using the new alert rule. Here, first, we need to choose a resource, and in our case, it's the LinkedIn Products API. Next, we need to choose a condition. Let's go ahead and add a condition. In here, we need to choose one of the metrics. For our case, let's go ahead and choose requests, so we can set up an alert based on requests. But the signal could be anything. We can see the size of Event Hub events or total Event Hub events, network connectivity status, anything. Let's go ahead and select the request metric. Now, we need to select dimensions. Here, on the dimensions, first, we need to choose a dimension. Let's go ahead with Gateway Response Code category. So, basically, whenever a request fails, we want to be notified. And next, we need to select the value. We are going to select requests with 400 status code and 500 status code. Up next, we need to choose the alert logic. Here, we want to set up when this alert will be triggered. For the operator, let's use greater than. And for the aggregation, let's go with total. And now, we need to set up the threshold value. In here, we are going to say that when do we want to be notified. So, if 10 requests in total, 100 or 500. Let's go ahead and say 5. If 5 requests fail, then we want to be notified. And we're going to leave the unit as count. So, if a total of 5 requests fails, then we want to be notified. And finally, we need to choose the aggregation period. Let's go ahead and make it 1 minute. This means that if 5 requests fail per minute, then we want to be notified. And let's finalize the changes using the Done button. Now that we set the condition, we need to set an action. Let's go ahead and add a new action group. I've already added one, but to demonstrate, I'm going to create another. In here, first, we need to choose the resource group and then the action group name. Let's go with API Administrators. And now, let's move to the notifications. In here, we want to specify the notification type. Whenever this action is triggered, the notifications will be sent. For our demo, let's go ahead and send an email. And now, let's go ahead and configure the email. We can also do SMS or other notifications. For our demo, we are going to go with email. And we can add other people as well. In here, we would include all the people that we want to be notified. Let's go ahead and provide a name. And now, let's move to actions. In here, we can automate something. Whenever an action is triggered, then we can call a webhook or Azure function. For our demo, we don't need to automate anything, so let's go ahead and review and create this. And now, let's finally create our action group. Now that we have the action, let's give the rule a name. We also can provide how severe a role is. In our case, it's set to informational, but let's go ahead and make it critical. And now, let's go ahead and check the checkbox, so our rule is enabled upon creation, and let's create our rule. If we go to Manage Alert Rules, we should have our API email alerts. I'm going to delete the previous one so we don't confuse the two. And now we only have one alert. In order to trigger the alert, let's go ahead and navigate to the developer portal and call our API. Let's go ahead and call one of the endpoints in the developer portal. Let's go with products. And if we make a couple of calls, we are not providing any authentication, so they should fail. After a minute or so, the condition should be met. We have 5 failed requests under a minute. Let's go ahead and check the alerts page. And here we can see now that we have 8 alerts and one of them is critical, which is the one that we created. And our API email alerts has been triggered. And then here we can see why did it fire, we can see the request that came in. Now we should also have gotten an email from Azure indicating that the alert was triggered. And indeed we have an email. It indicates the rule ID, the resource ID, and then the metric name that we created. Using alerts is a great way for us to know when our API is in trouble, so we can go in and fix it. This way, we don't have to worry about checking logs constantly and making sure everything is okay. The API will let us know if something is wrong and why it is wrong. In this challenge, I'd like you to create an alert for our API. The action should be that it sends email notifications to yourself or others. And it should trigger when the number of requests with status code 500 is higher than 10 in a period of 1 minute. Once you are done, join me in the next clip to go over the solution. To solve this challenge, from the Alerts tab, I proceeded to create a new alert rule. I left the scope as LinkedIn's Products API and added a new condition. For the signal type, I chose requests. And next, for the dimension name, I chose Gateway Response Code category. And for the dimension value, I chose 500 error codes. For the operator, I left it as greater than and set the threshold value to 10. And changed the aggregation granularity to 1 minute. Once I created a condition, I proceeded to create an action. I named the action Challenge Group and proceeded to create notifications. For the notification type, I chose Email, SMS, Push Notifications. And I added my email here in the email section. And left the rest of the setting unchanged. I also provided a name for the notification and finally created it. As a final step, I gave my alert a name. And finally, created the alert rule. Thank you for going on the journey with me to learn about creating APIs using Azure API Management Service. Hopefully, you now feel confident to start deploying your APIs and consume them using the API Management Service. If you'd like to build upon the skills that you learned here, I suggest creating and deploying your own APIs. And try applying different policies to get confident in creating them, as they are one of the most important topics for Azure API Management.